All right, which of these following substances dissolve to a significant extent in water? Explain your answer in terms of interactions between the solvent and the solute. So we learned that when we learned about study the energetics of the heat of a solution, that energy that it takes to expand, so the delta H of expanding the solute and the delta H of expanding the solvent, the intermolecular forces between the solute and the solvent have to be similar in order for the delta H of mixing to be significant. So we want that to be very exothermic, because if this overall process, whatever the difference is, we call that the delta H, or the heat of solution. If that is too positive, if that's way greater than 0, then the solute and the solvent are likely not to mix. So we want the heat of solution to be negative if possible, but that doesn't always happen. So if it's close to 0, there's another factor called entropy that make this a spontaneous process. The bottom line is the intermolecular forces between the solvent, in this case water, is polar, and the solute, right? So the solvent and the solute, their intermolecular forces need to be similar. That way this delta H of mixing will be significant. They'll be attracted to each other more, which will in effect make this much more exothermic, which will make this substance soluble. All right, so let's go through these. A is not going to work. We just did this in our previous video. This is methane. That's nonpolar. Nonpolar substances are not going to be very endothermic, and water's not going to want to mix with that, so the delta H of mixing is not going to be very significant either. So this is not going to happen. Not soluble for A. B is going to be soluble because that is an ionic compound. Not all ionic compounds are soluble, but this one is. It's an alkali metal and a halogen. So we know this is polar ionic. That's going to be soluble. Yes. Helium is not. This is a nonpolar gas, just an atom. So it doesn't have any bonds actually. So that's not going to dissolve in water to any significant level. And then this is also an ionic compound, and our solubility rules say that sulfates are generally soluble. Magnesium is not an exception, so this is ionic. So the interactions between the solvent and solute, they are going to interact significantly to make this delta H of mixing significantly exothermic, enough to make this a soluble. Sucrose is polar, so that's also going to work. Right, sucrose is table sugar, and so water's polar, sugar's polar, they're going to dissolve. All right, delta H of mixing is going to be significant enough for this to make it soluble. This is another ionic compound. We have sodium and then the bicarbonate ion, so this is, you can say, is also ionic, so that's also going to dissolve in water.